Hello, welcome to another module in this massive open online course. So, we are talking about recommender systems, specifically the relevance of linear algebra in the implementation of a good recommender system, which has significant applications, as I have already told you, making recommendations on any commercial website, be it e-commerce or video streaming, movie streaming and so on, such as even YouTube, which recommends videos, right. Along with commercial sites such as Netflix and so on. So, let us look at an example to understand this in action, a simple paper and pen example of a small system to understand how this such a system can be implemented in practice, right. So, we are looking at recommender systems or a recommendation system, and now let us look at an example to understand this better, an example of a recommender system for, as we have said, similar to what we have seen yesterday, a movie recommender system, right, which would the kind that would be that could be employed on a movie streaming website, right. So, we have, let us consider a simple example. Let us set k, remember, is the number of movies. Let us set k equal to 3 and L, which is the number of users. You will remember L is the number of users. Let us set this also as 3. And remember, we have this recommendation of movies, that is the table with users and their recommendations. So, the columns are essentially the movies and the rows are the users. So, for instance, we have 3 users and 3 movies. This is your K, this is your L. Let us put in some sample recommendations. In this example, let us say the recommendations are as follows. So, we have 4, 3, 2, 2, blank, 3, and user 3 has recommended 2, 4, 5. So, you understand the meaning of this, which is basically the recommendation of the rating. So, 2, this is rating of user 1 for movie 3, right. So, I j, we look at this as a matrix. I is the rows are the users, columns are the movies. So, I j, that is 1 comma 3, denotes the rating that user 1 has given to movie 3 and user 1 has given a rating of 2. And similarly, user 3 has given a rating of 2 to user 1, right. Now, this in between, that is R22, the user 2 has not seen movie 2 and this rating has to be predicted. So, R22 is unknown, this implies R22 has to be predicted, that is, we have to have a formula estimate R22 hat, right. So, this is the estimate and we want to ask the question, what is R22 hat, what is the best possible estimate R22 hat of R22, which is the rating user 2 would probably give to movie 2, had he watched movie 2 based on, and look at this, very interesting, based on the ratings that user 2 has given to other movies and also based on what other users have rated similar movies and so on. So, it's a very it's a there are layers of complexity in this problem, and which makes it a very interesting and a challenging problem, and of course, a lot of applications, as I told you, in the modern era. Okay. Now, the first step is, as I told you, to find the overall bias, that is your RA, which is equal to, for instance, take all the ratings that are there, which is basically the sum of all the ratings, and divide by the total number of ratings, which you can see is 8. So, this would be 4 plus 3 plus 2 plus 2 plus 3 plus 2 plus 4 plus 5 divided by 8. You can see 8 is the total number of ratings. This is basically your the total number of ratings, and these are essentially all the ratings, and this RA, this overall bias, this RA, you can evaluate it. This comes out to be 25. This comes out to be 25 divided by 8, which is equal to 3.125. So, this is your the overall bias. Remember, that is basically the sample mean of all the available ratings. Subtract the overall bias to get the unbiased ratings, right. So, you have R tilde, this is basically R ij minus R a. For instance, R tilde 1 1, this would be R 1 1 minus R a, which is R 1 1, as you can see, this is 4 minus 3.125, this is 0.875. So, R tilde 1 1 is 0.875, and so on and so forth, and once again you can form this table here for these R tilde that is after removing bias. After removing RA, and these quantities you can see, these are given as 0.875 minus point. So, let me write these down, let me take a little bit of space. 0.875 minus 0.125 minus 1.125 minus 1.125, and this is of course blank, minus 0.125 minus 1.125, and this is 0.875 1.875. Okay. So, these are after removing the bias. For instance, this you can see, this is your R tilde, 3 comma 2, which should be rating of 3 for user 2, that is 4 minus R A. So, this is R 3 2 minus R A, that is 4 minus 3.125, which is 0.875 and so on. Now, the interesting thing here is, as we have seen yesterday, we consider a simple model where R tilde I j equals U I plus M j, the bias of user I plus the overall the bias for movie j, which you can say depends on the inherent qualities of movie j. All right. So, you can say R tilde I j equal to U I plus M j. Now, what is U I? This is the bias of user j, and this is something that is depends on the overall bias for movie I, which depends on the characteristics of movie I. Which depends on the characteristics of movie I, and therefore, for instance, now I can write R tilde 1 1, which is 0.875. This I can write as U 1 plus M 1, bias of user 1, and this is bias for movie 1, and this is movie 1. Okay. And therefore, now we can form our system of linear equations. So, next step is form the system of linear equations, which explains and in this you have the vector, which is all the available ratings after removal of bias. So, you will have 0.875 minus 0.125 minus 1.125 minus 0.125 minus 0.125. I am sorry, this has to be minus 1.125, 0.125 minus 1.125, 0.875, 1.875. This is your what we are calling as the vector R tilde. We can write this as the matrix. So, remember, this is an 8 cross 1 vector. So, 8 is the number of available ratings, that is, remember, this is for all and this you can write this as this matrix C, which we are calling as the matrix C. And let us write this appropriately. This I can express it in terms of the movie biases, the user biases and movie biases, that is B1, B2, B3, M1, M2, M3. These are the biases So, this is 6 cross 1, that is you have your, remember this is L plus K size vector, L equal to 3, K equal to 3. So, this is, remember, L equal to 3, K equal to 3. So, this is a 6 cross 1 vector, and you have the matrix which relates these ratings, this R tildes to these biases. Okay. So, essentially you have 0.75, 875 equal to B 1 plus M 1. So, I will have 1 0 0 1 0 0, and this is for instance your R tilde 1 1. This is for instance the next entry is R tilde 1 2. So, this would be B 1 plus M 2, that is, so this will be 1 0 0 0 1 0. Next is your R tilde 1 3. So, this will be B 1 1 0 0 plus M 3 0 0 1, and so on. You can form the other rows, and it is not very difficult to see. Fourth row will be B 2 plus M 1. So, this is 0 1 0 1 0 0 0 1 0 0 1 0, then you have 0 0 1 1 0 0 0 0 1 0 1 0 0 0 1, and this is basically equal to your matrix. Not sure what we call this, let me just look at the nomenclature. So, I think we call this as the matrix C. Alright, so we will call this as the matrix C. This is your matrix B bar, and you can see the C naturally, this is an 8 cross 6 matrix, implies number of rows greater than number of columns. This implies this is a tall matrix. That is what we have seen yesterday. Remember in the previous module that the number of rows is much larger than the number of columns, typically because columns represent the biases which are much smaller compared to the number of ratings. The number of ratings available is basically huge, right, and therefore, you have a tall matrix, and which now you have R tilde equal to C B bar. This is the bias vector. Therefore, this is essentially, go back to, this is an overdetermined system. So, this implies your B bar equals C pseudo inverse. I hope you remember this notation, C dagger, that is C pseudo inverse, which is C transpose C inverse C transpose R tilde, and if we do that, what we get is essentially you get the vector let me write it down, minus 0.1042 minus 0.5208 minus 0.5625 minus 0.4375 0.1458 and 0.2292, and therefore, and now you can see these correspond to the values. This is for instance your U1, this is U2, this is U3, this is M1, this is M2, and this is M3, and therefore, now how to get the prediction? Now, the only thing that is unknown, remember we said we have to predict R hat 22, we have to predict R 22, that is R hat 22, and R hat 22 is U2 plus M2, plus of course not to forget the overall bias, right. So, do not forget that. So, R hat 2 2 equals U2 user 2 bias plus M2 bias for movie 2 plus RA. So, you can write this as or let us put RA in the front, RA plus U2 plus M2 which is equal to 3.125 plus U2 which is minus 0.5208 minus 0.5208 plus M2 that is 0.1458 which implies R hat 2 2 equals 2.75. So, this is our prediction of user 2, prediction of rating. So, what have we achieved? This is the prediction of rating of user 2 for movie 2, and remember, right, the next step is of course to compute these predictions of the ratings of unseen movies for all the users and ultimately recommend that movie which has not been seen previously by the user and that has the highest predicted rating. Alright, that is the last step. Of course, here this is a simple toy example. So, we have only one movie that is unseen by user 2. So, of course, we do not have other unseen movies for which the rating can be predicted and so on. So, essentially this example will stop here where we have simply computed or predicted the rating of user 2 for movie 2 which he or she has not seen before. The logical conclusion would be of this for a large system would be the last step would be to compute such predictions for all the movies that all the users have not seen and ultimately recommend to each user the movie with the highest rating from among the movies that particular user has not seen. Alright. So, let us stop here and let us continue discussing other such interesting applications in the subsequent modules. Thank you very much.